Hello and welcome, or ciao e benvenuto al nostro nuovo podcast di Tapas e Prezzo. So that was Italian. Maybe I pronounced it right, maybe not, but I tried
That's right.
my best. Perfect. So what does it mean? Of course, we have a new host for today, and that's Andrea Gioia. Gioia?
Gioia.
Gioia. Okay, Gioia. He is the partner and CTO at Quantica and co-founder at Blindata. And we also have discussed before we started this podcast, there are a lot of topics for data and a lot of questions that can be raised. So, Andrea, you also write a book, right? That should be released maybe like end of September or like October. So what questions do you think should be arised in the topic of, for example, data as a product? If you can say something about that.
I think the first question is why we need to manage data as a product, and then the second question, what does it mean to manage data as a product? So I can start from these two questions that are, of course, the first question I tried to answer in my book, now just to set the stage. So why we need to manage data as a product? Because basically managing data and create data management solution is a very complex endeavor, not only related to the complexity of technology, but also related to the complexity of the organization and the operating model that you need to put in place to create this kind of solution. Traditionally, in the field of data management, we have built a big centralized system, monolithic centralized system, both from the point of view of the architecture, of the technical architecture, but also from the point of view of the operating model. And what we have seen in the past 10, not even 20 years, is that this monolithic solution, the complexity within this monolithic solution tend to grow over time without any kind of control. And some point in time, the complexity is so much big that is not anymore manageable by the team that developed the solution. And so the solution tend to become a legacy system that costs a lot to be maintained, and it is very, very slow to produce new functionality, to integrate new data. No? So in the data management field, what we have seen in the past is that every 3, 4, 5 years, the solution that we have built are replaced by new solution developed from scratch on the new technology. But of course, this way of manage data is not sustainable in the long run. You cannot have 3 or 4 data management solution and have to maintain them in parallel. So what we want to do is to create a solution that can evolve over time, and they do not collapse under the weight of the complexity that they generate while integrating data. So here it comes the concept of managing data as a product, because in engineering practice, every time that we need to manage a complex system, the better strategy to do that is basically dividing the system in a smaller part that are more manageable, that segregate the complexity and allow the team that developed the solution to do modification in isolation, in a single part, without having to worry too much about the intricacy of the rest of the system, because they do the modification in a specific module that is isolated and as much as possible decoupled by the other part of the system. And when it comes to data, this modularization, this unit of modularization is what we call the data product. Okay, so it's important to manage data as a product mainly for this reason, to create solutions that can scale very fast, that are built by composition of smaller parts, can scale very fast, but more everything that can evolve over time, and that does not need to be recreated from scratch every 5 years. So that's why it is important to create scalable and sustainable solution over time, solutions that are not monolithic, but that are built as a composition of models. this answers the first question. The second question is, what is a data product? This is a very complex question. There are a lot of definition. All the definition are valid, but usually this definition do not converge very much. There are different aspects that are more underlined in one definition than the other. Of course, in my book, I have think a lot of to come out with my definition of what is a data product. So basically for me, a data product is a software application. Is a software application that provides some functionality, and this functionality respected to a transactional application not only use data. Transactional application use data because the transactional application needed to store the data that of the entity they process, in order to provide the functionality. But the data is just a byproduct for transactional application. In a data product, instead, the data drive the design of the functionality. So the data is core in a data product as an application. Of course, it's not just any kind of application. It's an application that is developed over time following the principle of product management. So it's a piece of software that have a life cycle, that have a clear product owner, that try to resolve a specific business problem, providing outcome and not just delivering a feature over time with a project approach. Inside the field of what I have defined as a data product, I define two main subfamilies of data product. On one side, we have the analytical application that are the data product that provide functionalities that support a specific use case and can be consumed by the business user. So, for example, provide a visualization of the data, a recommendation made using the data. These are applications, have functionality that can be directly used by the final user, and probably even these functionalities do not expose the data directly. Expose some action that can be performed, some optimizations, some recommendations, some visualization. On the other side, there are the pure data product, what I call the pure data product, that are applications that through their functionality just expose pure data, expose a data asset that can be reused to support multiple use cases, to support multiple analytical application, or to support even transactional application in doing their work. And this part is very important for me. The book is concentrated mainly on this pure data product because if every time we have a use case and we implement an analytical application, this means that every time a new use case appears, we need to re-implement all the part related to data integration in order to support the use case. Instead, when we have a use case, first of all, we implement the pure data product that support the application that then support the use case itself. This pure data product can be reused also for supporting other analytical applications, other use cases in the future. So we create a library of building blocks that can be recomposed, reconfigured, reused over time to support multiple use cases. If we follow this approach, use case after use case, this library of pure data products, this building block became bigger. And there is a lot of probability that a new use case does not require anymore to do integration, but I can implement a new use case just by recombining the pure data product that I have already developed in the past. So basically, I can start to have an approach that is composed to order. When there is a demand, I have not to rebuild everything from scratch, but I can reuse the component that I have already developed. Instead, without having the pure data product, but just only analytical application, basically I'm forced to follow an approach that is make to order. Every time I have an order, I have to rebuild the full solution from scratch, from the ingestion of the data from the source till arriving to the visualization. And so this is not sustainable. It's modular. Is a modular solution, yes, but the module cannot interoperate and cannot be composed and reconfigured for different use cases. Are basically siloed application. It's a collection of siloed application. Make sense?
Yeah, it makes sense. I have one question.
Yeah.
I would like to comment one thing. The same happens with APIs that also can be considered a product. Sometimes, quite often, more than decide, I think, we tend to put the focus on the producer part of the life cycle. How are you managed? How can you manage your consumer part of the life cycle?
The consumer part of the life cycle, I think that the parallel is very correct, because basically we are not reinventing the wheel in the data world. When I talk about a product as a software application, I mean exactly as a software application. So a product should have API, should have a service agreement with the consumer. So basically the concepts are really the same. The difference is that usually you have a product with an API that provides a functionality that can modify some business process, more on the transactional side. The product is more concentrated on reading the information, but it's the same. Sorry, it's the same. So it's an isolated a unity that you can deploy in isolation with a team that manage the data product exactly as a microservice or as a software application. The problem with the data product, and there is a difference between a data product and microservice when it comes to consumer, is that for the data product, especially for the pure data product, when you design it, you do not know exactly what use will be done by the consumer in the future. Now, of course, you are designing and implementing the data product to solve a problem, and probably you have already a use case that you want to support. But then, because you design it for reuse, probably it will be reused in the future in a context that are not, for example, when you design it in the first place. So there is this difference that is important. But for the other part, you come out with an API, you come out with service agreement or data contracts, like, because in the data world we like to call things that already exist with other name, but it's not a problem. A data contract is a service agreement. So you come out with a clear interface that decouple how you have built the functionality from how the consumer assess the functionality, and you need to respect this contract in order to not break your consumer downstream. But you do not know your consumer in advance. You only know what you are declaring, the interface that you are declaring, the API that you are exposing, and then you have to remain consistent with that API over time to not break the downstream consumer.
So what triggers me currently is basically, I think you have explained it really well, but what is your recommendation, like from a pure business point of view? Why should I do it? Like, is it really the ease of integration? Is that the case? Or like, when I currently thinking, everyone currently talks about AI, and that we have currently reached the peak of in the Gartner hype cycle, basically about AI.
Mm-hmm.
There will be a huge downwards until people really recognize. Where do you see the current and the more strategic potential for the business side and adapting data as a product? Can you maybe say a few words about that?
Yes, I think that let us set the artificial intelligence for the moment, but just look at the business and the context in which the business try to operate today. Now we are in a very volatile world, in a very uncertain world, so it's difficult to know what will be happen in the future. So organization have to organize themselves to be very good in adapting fast to the different situation that can happen. So it's not more the situation in which you can predict what is going to happen in 2 years, and then you can build your strategy as a plan that you execute to achieve some goal, making a prediction based on the prediction of what will be the future in 2 years. No, so what you can do, what you have to do is to create optionality, to create different options and create a structure in your company that can adapt very fast. Of course, as I said before, a monolithic structure, but from an organizational point of view and from a technological point of view, is not something that can be adapted very, very fast to the different situation. Every time you need to change something to adapt to a new situation, you need to do a lot of work against the monolithic system. Instead, if you have a lot of modules, and I say that a product from a technological point of view, but also the teams that manage this product are modular and work on different products, then you can reconfigure very fast. No? So if you have a new need, you can reconfigure very, very fast and answer very quickly to the demand of the business that change very fast and ask for a great level of differentiation, personalization, the concept of having a corporate report, so having 10 report that satisfy all the company. Yes, you have to define this report, but it's not enough anymore, no? And you are not able to predict what are your analytical needs in the future because you are not able to predict what are the problems that the company will face in the near future because the world is very volatile. So modularization at all level within the company is very important right now, and it is also important in the data world, of course. Talking about artificial intelligence, what is an artificial intelligence is an information system that takes some data and produces some data as an output. So basically, the first thing that I have learned at the university is that in information system, there is a principle, trash in, trash out. No? So if your data is not good and you put this data into a system, it's very difficult that come out some insights, some goal, some value. No? You need to have data that have very good quality, and then you can produce. Then you can have terrible algorithm, but if the data is okay and the algorithm is okay, you can produce a good insight, a good output. If you have a best in class algorithm right now, a best in class artificial intelligence model, and you have very low level quality data to put into the system, the output will be bad. Probably a good enough model with very good data outperform a top of the class model with bad data. No? And in fact, in artificial intelligence, since I think a couple of years now, there is this movement of data-centric artificial intelligence. No, so do not focus on optimizing the model too much. The model that we have are already quite good, but focus on optimizing the data, the quality of the data, because optimizing the quality of the data is the best way to improve the performance of the model. So not work on the model, not optimize the model, but optimize the data in order to improve the overall performance. This is for traditional artificial intelligence. Then now we have generative artificial intelligence, and the fact that you need to have a very good data still remain. But for generative artificial intelligence, it's very important also to have a very, very good metadata, because large language model, generative model, basically are super intelligent, but are also super stupid at the same time, because they know a lot of things, but they have no common sense, and they do not know anything about your business domain. Okay, so you need to try to provide some common sense and some information related to your business domain. But the problem is that to provide this information, you have a limit. You cannot pass a big chunk of information if you are doing prompt engineering. So if you are talking with the model, if you are creating a new model from scratch, but a lot of companies have not enough money to create a large language model, a private large language model. But if you are using one that is available on the market, you have to pass the information. But there is a limit of the amount of information that you can pass in to the model. So metadata is a way to provide the context in a complex way. You can pass all your database of data. It's not possible. It's too big. You have to find a way to represent your information and make it smaller in order to have the possibility to pass it to the large language model. And this is performed basically through metadata, especially through semantic metadata, so through conceptual model. By describing your business context, what is the common sense of your way of operating through a conceptual model. Then you pass the conceptual model, and then you can ask a question to the large language model, and the large language model answer with the knowledge of the context, so reduce the hallucination and gain some common sense of what is acceptable in your business and what is not acceptable.
To common sense is not very good.
It's not very common. Common sense is not very common, but for sure, large language model have no common sense at all.
So any improvement is welcome,
Exactly.
Yeah, I just yesterday I read. Okay, it not was yesterday. It was during the weekend, but yesterday I make some post about that. I found out the concept of composable AI. Composable artificial intelligence means to link data ops and then machine learning ops and then API ops. What do you think about that? Because it's very aligned with to what you are saying. We want to reduce the time to market of the data, of the data as a product. So hyperautomation plays a key role on that, reducing that time.
Absolutely agree. I think that we are. I think just looking at data management and artificial intelligence, I think that it's very important to create an architecture, an infrastructure, a platform that is integrated and convergent to manage data and artificial intelligence. Create two different stack, separated stack, managed by two different C-level is not the way to go, because you are managing the data. Data have no value. By itself, data have no value, have value only in use. And now the most valuable way to use the data is probably through artificial intelligence. So you are managing the data because you want to provide this data to the final user, but also to intelligent agent, to artificial intelligence. No? And so recreating two stack to do similar thing in a different way, it's a waste of money, basically, because you're creating basically you have to version your model, you have to version your logic, but this is the same from data management and from artificial intelligence. You have to manage your metadata, but it's the same on the two worlds. So why having two different tools to do that? It's better to have a convergent platform with the same tool that can help the two worlds. And I think that this convergence and this automation is something that will going on also between the data, the analytical world, the data management world, and the transactional world. No, for a long time we had different way of managing API, version control, DevOps. There is a different name in data management for every concept that we have in software development. There is DevOps, we have data ops. There is data versioning, you have code versioning. So, but basically are the same tool with a very small differences, So why having two stack, and now why having three stack differently to do the same basic operation, no? So I believe that now probably I think that Gartner called this XOps platform, no? A platform that is able to manage different operational concern, not only data, not only security, not only FinOps, but an integrated platform that can manage operation across transactional data and IE world, no? Because are very common and are part of one value chain within the company. No? So why create different stack and create segregation when there is no need to do that?
Which totally resonates with me, because what you said earlier is basically the concept of modularization. Basically, as an organization, you want to have the flexibility of being modular, because then you can put the business experts, the domain experts, and the data experts into one single unit that is responsible for the data and the data quality, and also for the we discussed earlier, that the agent is basically the part of the company that has an exact knowledge about a domain that can be provided as an agent. If the company works as an agent-based, federated concept, so to say, this is basically the outcome the business is looking for. Like, if you want to really work and talk to your data, like put the expert and the IT together in one unit. I mean, then we can have divided into multiple C levels, whatever. But as long as they have standards to talk to each other, then you can really leverage your knowledge in the company.
Absolutely.
Yeah. Just summarize, because like everything, like my head had so many single pieces, and I just wanted to wrap it up a little bit.
But I think that this is domain-driven design. No? You want to design solution within the domain, but the data product are part of the domain. So basically, within the marketing domain, let me say, the application of the marketing domain speak an ubiquitous language. But this ubiquitous language should be also the ubiquitous language spoken by the data product that belong to that domain. The business expert that is involved to create a model of the domain is the same for the data world from the transactional application. Why divide these two parts? They live in the same domain, no? It's an application that produces data and another application that exposes functionality, but they have to talk the same ubiquitous language and refer to the same domain expert to create the solution. Maybe solution more related to analytical world or to transactional world, but speak the same language. Then the problem come out when you need to integrate data across domain. But also, this is a well-known problem in the domain-driven design that have the concept of context mapping. No, so we can apply this concept of context mapping even for data product that need to compose data across different domains.
Absolutely, as you said, like we need to converge like these operational and this analytical world, because like both concepts from the software engineering and the data world are exactly the same. Maybe some have been established before, but others are still there. Yeah. What is your view on like this like data fabric versus data mesh approach? Like, do you have any preferences here? Just switching topics.
I have been too long in the data management field, and I've seen a lot of different approaches to data management, and I believe that it's very important to know all the approaches, and then it's really impossible to implement them by the book. You have to take according to the different context and goal of the organization you are working with, the good part, what makes sense in that context. So you need to be fluid, not to be too much as a religion. Okay, I'm doing data mesh as a religion and I apply it out of the book. I think that, and this previously, that the last Gartner event in London next week, so in not suspect time, I think that there is a lot of correlation between data mesh and data fabric, mean that are not, you have not to decide if you want to do data mesh or do data fabric, but they can work also together, because data fabric is really focused on the technological part. So what is the platform that you need to put in place from the technological standpoint to support your data management initiative? How you need to collect metadata in order to provide automatization and reduce the manual work that you need to do when you implement a data management solution. So it's very focused on metadata, automation, technology. Okay. Instead, data mesh is more related on the social part, no, the operating model. How you have to organize your team to create a data management solution that is scalable, but it's more related to the operating model, no? So because when you create a solution, the operating model is very important. It's the first thing for me to define the right operating model according to the goal that you want to reach in your technical architecture. But then it comes the technical architecture, because you have to put in place something that supports the people to execute the operating model. So basically, you can have a data mesh approach with a fabric that support the generation and the automation of the life cycle of the data product itself. No, in the data mesh there is these two very important concepts that are the self-service data platform that support the product team to develop their their data product, and there is the concept of federated governance that define the rule that the platform try to enforce and try to also supply functionality that make more easy to the developer team to implement products that are compliant with this rule. No? And this self-service platform that is designed according to the rule of the federated governance basically can be the data fabric. Can be the data fabric, because when you design it, you find out that you need to have metadata. You find out that you want to automatize as much as possible. You find out that you need to have conceptual model, the knowledge what Gartner called correctly the knowledge graph to create interoperability between the different data products. So basically, you find out that you are creating not as a service platform in general, you are creating a data fabric. So I think that they can work together in a lot of situations. They can be implemented together.
And one question from my side in that case. So you said you have or had a lot of companies where you integrated something concept like data mesh or data fabric or the combination of two, yeah. What would you say, like in the future, do companies is this just a start? Are there already companies that are using this like as a whole religion, I would say, or do they also face some issues with it? So do you also see some problems that maybe could occur, or what do you think about that topic?
I see 1 million problem every day. Yes, I see that. I think that the company that have started and to apply these approaches as a religion by book probably have failed badly. But companies that are more pragmatic and are able to define their strategy in an incremental way, so trying things that come from the different model in incremental way, assess the value, and then maybe change it a little bit, adapting, so that this incremental approach to the strategy implementation, not as a plan. Okay, I take the book. This is the data mesh. 2 years we will have a data mesh implemented by the book. This is the way to share failure. Instead, if you say, okay, we like the data mesh, we like the principle, we want to implement where we are now, what we can do in the next iteration, and then after the next iteration, find out what went well, what went bad, what can be improved, and have this iterative approach. Basically, these companies are facing problem every day, but move on in a sustainable way. So if you ask me, there is a single company that have implemented data mesh by the book today and is and will live happy forever after that? No, they are always trying to improve, but there are companies that I work with that gain some real value from this kind of approach. They are not yet perfect, but they never will be perfect, because the situation change every time. The organization, the strategy, the business strategy of the organization change every time. So they are always building up, but they have already gained some value from this kind of approach, because I think that basically it's quite understandable. It's difficult to change the organizational model. That's every kind of modification that you are trying to do organizational is difficult. It's more simple to change the technology. It's more simple to buy by the shelf one technology than say, now we need to change the way the teams work together. But I think that the only way that we can survive in the data management is through modularization. So maybe not all the principle of the data mesh have been applied in all the company, but the concept of data product is very central. So think modular. Think about the software world. It's not thinkable anymore today to have a large system that is not modular, that is a monolithic, one single block. No, it's unimaginable. Instead, is the way of working that we have in data management and we have applied to data management for so long time. No? So when you start to modularize it, after some time, you find a lot of value from this approach. Then there are a lot of problems also to solve, but I see some value there, and I see that a lot of companies start to see this value once they are started to approach this kind of paradigm.
And again, it's divide and conquer. Divide and conquer the fundamentals, the principles.
Yeah. From Roman, so
Yeah. Again,
So
thank you, Andrea. Or do you have another?
no,
No.
no.
No. Okay.
I was only to ask Andrea to summarize everything in a headline, but it's very difficult.
No, I think that a good headline to summarize is divide and conquer. So we are doing a complex, a complex work in data management, and if you don't want to become crazy and rebuild things every 3 years, you have to divide and conquer. It's a simple thing. It's a simple thing. All engineer practice that have to manage complex system do that. Why we don't?
Yeah, but it's also a very important topic, I would
Yeah.
say. Maybe the most important topic. That was just my suggestion right now. So thank you very much, Andrea.
I agree, because if I can add only one thing, the complexity is how you divide the big system. It's not an easy handover. Second for another podcast, but dividing in the right way, it's not so simple.
Yeah, that's true. So thank you, Andrea, and all of you that you were here. It was a really interesting podcast, and we will see us at the next time. And just grab an espresso after that nice meal right now.
Yes, sure. Thank you for having me. It was a pleasure.
thank you, Andrea.
Sure.
Thank you. And we see us next time. Bye.
Bye.